This video is going to cover multiplying and dividing radical expressions. So first we'll do multiplying. If you need dividing, just skip ahead a little bit. So when we multiply radical expressions, we see that if we have two of them being multiplied, well, we can combine the values under the radical sign. We can multiply them. So if we look at example number 2 here, there's two ways we could think about it. If we follow the pattern we just saw, we can rewrite this as 81 times 36. I'm going to use Desmos to help me with that. 81 times 36, that gives me a very large number. So 2,916. And then we can find the square root of that. And when you look at that, it gives you 54. So that would be it for that problem. But you might have noticed something else when solving it. Hopefully you're going to start noticing those perfect squares. So 81 and 36 are both perfect squares. So you could also simplify this by seeing that the square root of 81 equals 9 and the square root of 36 equals 6. So we could treat this as 9 times 6, which also gives us 54. So that's not always going to work that way, because if you don't have a perfect square, it's not going to simplify evenly like that, but in this case it did work. All right, looking at example C over here, the same pattern follows for variables. So for these, it's very helpful to go ahead and just multiply everything under the radical. So 72 times 10, 720. X cubed times x. Well, remember that's like a little exponent of 1. So x cubed times x to the first power. We add the powers, 3 plus 1, so 4. So x to the fourth. And then same logic, y squared times y cubed. We add those exponents, 2 plus 3 equals 5. So the next thing I need to do is simplify all this information I have. First, I see the 720, which is a very large number. So I'm going to go ahead and just see if it's a perfect square. Unfortunately, it is not. It gives us a decimal. So I need to find some factors of 720, and ideally one of them might be a perfect square. So thinking of our perfect squares, I'm going to try a larger one, maybe 12 squared, which is 144. I got lucky because that equals 5, so those are some nice whole number of factors. So I'm going to rewrite 720 as 144 times 5. And then this x to the fourth, I'm going to rewrite that into pairs, into sets of x squared. And then last but not least, I have y to the fifth power. So if I think about y to the fifth power, that's 5 y's. So I can get 2 pairs, but I'm going to have 1 left over. So I'm going to write y squared times y, my little leftover. Okay, now I can simplify. So we can split all of these things up. All of these under their own square root. Okay, so the square root of 144 is 12. Square root of 5, that cannot be simplified, so I'm just going to copy that down. Square root of x squared is x. Square root of x squared is x. And same thing, square root of y squared is y. And again, we get y. And then this one stays as the square root of y. Okay, this is not a good way to write your final answer. We want to rearrange these things. So we're going to bring all of these to the front and put our radical at the back. So 12, I have 2 x's, so x squared, and I have 2 y's, which is y squared. And then I have the square root of 5 and the square root of y, which I can just multiply underneath the radical. Because just like this property shows us, The square root of 5 times the square root of y is the same thing as having them multiplied under the same radical. And that's it. Now we're going to look at dividing. So we've got two examples here for dividing radicals. So when we divide radicals, it's the same pattern as multiplying. If we have radicals in the numerator and denominator, we can rewrite it so that the entire fraction is in the radical. But something really important we need to note is that you cannot have an answer with a radical in the denominator. So if we look at this first problem right here, right away I notice a radical in the denominator, so I need to fix that before I can do any simplifying. So to get the radical out of the denominator, we do what is called rationalizing the denominator. So I'm going to copy down this problem, 5 over the square root of 10. And to rationalize the denominator, we multiply by whatever that square root is in the numerator and the denominator. Because, little aside up here, if we have a fraction like, I don't know, 5 over 5, well, that just equals 1. So multiplying by 1 doesn't change something. So even the square root of 10 over the square root of 10, that just equals 1. So it's not changing the value of our expression, but it is going to allow us to get the radical out of the denominator. All right, so in the numerator, I have 5 times the square root of 10. And then in the denominator, what happens is when these get multiplied, remember what we learned on the last slide is that those are multiplied under the radical, which is the square root of 100. Well, 100 is a perfect square, which just equals 10. So anytime we're multiplying the same value under the radical and that's it, it's always going to simplify to that value without the radical sign. So my denominator here is 10. Now I can see if I can simplify this expression. So I have 5 times the square root of 10 over 10. Well, I see that 5 I could cancel and 10, 5 factors in twice. So I can rewrite this as the square root of 10 over 2. And I think about the square root of 10, so factors of 10 are 2 and 5, but 2 and 5, neither of those are perfect squares. So this is going to be my final answer because there's no more simplifying that I can do. All right, for this next example, we see that we have a radical in the numerator and in the denominator. They're both square roots, and so I can rewrite this as the square root of 18x to the 5th over 2x cubed. So now I could start by trying to simplify with the radical, but I could also simplify within this fraction. So 18 divided by 2, well, you can check it on Desmos if you need it, but that just gives us 9. And 9 is a perfect square, so that's going to help us along the way with solving here. So I'm going to rewrite that. 18 divided by 2 gave me 9. And then when we look at the variables, x to the 5th and x cubed, well, what that's saying is we have 5 x's in the numerator and 3 x's in the denominator. So we can cancel like terms and we're left with 2 in the numerator. So when we're dividing those, x to the 5th divided by x cubed, the answer is x to the 5th minus 3, which is x squared. And we saw that here, we're left with x squared. So I get x squared, and now there's nothing left in my denominator. So I'm just left with the square root of 9x squared. That's pretty easy to simplify because I can break that up. The square root of 9 times the square root of x squared. Square root of 9 is 3 times x. So my final answer is 3x. Great job.